Okay, in this video we're going to look at completing the square from a higher perspective, where we start dealing with non-unitary values of x squared. What I mean by that is anything where it's more than just 1x squared. So 2x squared, 3x squared, 5x squared, so on. Okay. Now at higher, these are worth usually 3 marks because you have to work out A, B and C, and you get a point for each of these bits. Now this just builds upon what we did at National 5. All we're looking for really is, first of all, to factorise to begin with, then it's half it, square it, minus it, as it was in National 5, and then it's a proper tidy up afterwards. We need to be able to do all of those aspects to be able to be successful with completing the square. Now, a lot of teachers, when they're teaching this for the first time, tell people that when they're factorising it to remove the common factor from all 3 terms. Now, that's all very well and good in this example here, because we'd have a plus 50, and then we take out the common factor of 2, this will come to plus 25, and then everything looks quite nice. However, when we start looking at examples further down, we've got plus 7. You start getting 7 upon 5s and try to add and subtract fractions together. It's not something that I particularly like doing, so I have a slightly quicker way of doing this. And it's personal preference as to whether you prefer taking out the entire factor of 2 and then dealing with fractions, or whether you prefer method I'm about to show you. So just as I did with my negative x squareds before, I took out common factor of -1 just here and left the third number alone. So that's what I'm going to do here as well. So these 2 terms have got a common factor of 2. So I'm going to remove that common factor of 2. I'm going to have x squared plus 6x, and the plus 50 remains untouched outside. I'm going to complete the square inside these brackets here. So what I mean by that is we've got 2. Inside these brackets is a squared bracket, an extra term, the plus 50 remains unchanged. So, as we said before, that x squared will turn into an x, the plus 6, half it, plus 3, square it, is 9, subtract it, there it is, minus 9. Okay, so we're almost there. We know that A is 2, we know B is 3, we just have to work out what C is. So to do that, I'm going to expand these brackets out a bit. So I'm going to have 2 bracket x plus 3 all squared minus 18 plus 50. So that's 2 bracket x plus 3 all squared. 50 minus 18 is positive 32. So you might be asked, what's the values of A, B and C as well? A equals 2, B equals 3, and C equals 32. Okay? Right, with that in mind then, here's a different example. And this is where my method of just removing a common factor from the first 2 terms will come in handy. So here we have it. We've got a common factor between these 2 terms of 5. So they can go outside the brackets. X squared minus 2x, and the plus 7 remains outside. So set of squared brackets, leave a space, plus 7 remains unchanged. This turns into an x. Half of minus 2 is minus 1. Then we square it. Well, square of 1 is just 1, and subtract it. So we know already then that A is 5, we know B is -1. Oh no, sorry, my bad. Negative B here. If negative B is -1, then B is just actually 1 then. B is 1. Be careful with that. I've seen people losing marks over that, and that just proves that I need to read the question as well. So multiply out these brackets. 5 bracket x minus 1 all squared minus 5 plus 7. Positive 7 take away 5 gives you positive 2. So 5 bracket x minus 1 all squared plus 2. C equals 2. Done. And just as I did at National 5, if you want to try these for yourself, make up some random numbers. I would usually go for having the first 2 terms having the same a similar common factor other than 1 and go from there. Okay, good luck. Thanks.